I got in my favorite student. Matt, my friend, what does every single exponential graph look like? Or, which means, you know what? Because I notice that the x is an exponent there, and the x is an exponent there, and the x is an exponent there, and the x is an exponent there, I can tell you the domain is all reals. And you can write the word all reals, or you can use the symbols. Oh, and because I know that log graphs are inverses of exponential graphs, I know the range is all reals for logs, because I literally switched the x and the y around. Okay. Matt, what does every single exponential graph look like? Do they ever hit the x-axis? Which means the log graphs will have no y-intercepts. There was a shortcut to figuring out the y-intercept of an exponential graph. Thank you. What was the shortcut? What was the trick? The y-intercept of this first one is 0, 4. The y-intercept of B is 0, 0.3. The y-intercept of C is, altogether now, 0, 9, and 0, okay. Not quite so easy to, we'll look at the x-intercepts of the log graphs and see if we can find a pattern. Equation of the asymptote. Now the asymptote was the x-axis. It got closer and closer to the x-axis. And the equation of the x-axis is y equals 0, y equals 0, y equals 0, y equals 0. Range. The range is either everything above 0 or everything below 0, but not touching. It depends on whether this exponential graph curves upwards or curves downwards, whether it's been flipped or not. That's the only one that's been flipped. It's going to be everything above 0, everything above 0, everything above 0, everything below 0. Then it says increasing or decreasing. Gets bigger or gets smaller. Well, that has to do, Mackenzie, with the base. Smaller than 1, smaller than 1. Each of these will look like that. A and C are, I'll put a big capital D for decreasing, or you can write the word decreasing. This one here is going to look like this. It's increasing. Mr. Dueck, what about D? Well, I can tell you what D is going to look like. It's going to be below the x-axis. It's going to be this thing flipped. It's going to look like that. I guess you could argue, since that's heading pointing down, you could call that decreasing. Although if you said, Mr. Dueck, it's increasing because it's getting further from the x-axis, although it's increasing negative, I'd take increasing there too. It's a weird one to describe in terms of increasing and decreasing. So I'd take either D or I, depending on your argument. 1 mark each out of 12. The The log graphs are the inverses, Mackenzie, are the inverses of the exponential. Some of this I can still switch the x and y around, reverse, and flip. For example, the asymptote is going to be x equals 0, x equals 0, x equals 0. The domain is either going to be x greater than 0 or x less. Well, no, it's not going to. You know what? For all of these, the domain ends up being, come here, x greater than 0, x greater than 0, x greater than 0. How do you flip a log graph? This one flips it vertically. To flip it horizontally, you'd actually have to have a negative inside there. You're literally switching the x and y around. So it's that. X-Intercept. Not so sure about C. You know what? Let's graph these. Menu. Graph. Clear whatever graph I have. And I'm going to go to my standard view window of negative 10 by 10. How do I graph log base 3? I don't have a base 3 on my calculator. Or do I? How do I graph log base 3? We did it in the notes. We did it in the homework. How do I graph log base 3? Look up. You need to know this. I go log x divided by log 3. That actually is a conversion for base. That'll graph log base 3. It looks like this. I have to realize that this tail keeps going down because my graphing calculator can't handle it. So can everybody graph that and then look up when you're done? Because I'll show you a few other cool things you can do with these graphing calculators. If you don't have a graphing calculator, now is your time to sheepishly fess up and I'll swap you. Everybody has one, I hope? Got a phone? So to type it in, exit, you're going to go log x divided by log 3. And then go shift view window standard, which gives you F3, which gives you negative 10 by 10, negative 10 by 10. And that should give us all identical graphs. So if you're there, can you look up? You're all there? If you look at this graph mark, right here, I'm kind of curious what's going on. I'd like to be able to, you ready? Zoom in. Press the, what's zoom? I'm going to show you one of my favorite zoom features. It's the zoom box. What's zoom box? F1. And what you can do with your arrow keys, using your arrow keys, go out to about here somewhere, up and left a bit. Once you've done that, hit enter or execute. And then if you go down and right, you'll see you're actually drawing a box. This is what it's going to zoom your screen into. This can be a handy way if you're trying to figure out what's going on in a specific graph, but you don't know what the dimensions are. You don't know what to change the window to. Use the zoom box. And if you now hit execute, it's going to say, okay, I'll zoom in on that area. And now I can say, oh, it is getting closer and closer without touching. I can see what's going on there a bit better. I could zoom box again if I wanted to. If I wanted to see what was going on right there. Okay. So zoom, box. That can be a handy one. If you have a graph doing something kind of weird, Taylor, and you're not quite sure what it's doing in that area. Okay. If you can't get that, now is the time to ask. Got that okay? Pause. Meanwhile, let's all zoom back to the standards. So Shift, View Window, Zoom Standard. Accidentally hit Dropbox. Close Dropbox. There we go. Zoom Standard, exit, draw. All of our graphs look like that. What's the X-Intercept? How could I find that out? Anytime I want to solve something on a graph, what button do I hit? G-solve. Now, X-intercepts are also called zeros, and they're also called a four-letter word that begins with R. They're called roots. So when it says find the root, if you hit F1, there's my X-intercept of 1, 0. By the way, would you say, is this graph increasing or decreasing? Is it getting bigger as we move right or getting smaller as we move right? Increasing. The one I'm kind of wondering about is B with that negative there. So let's go back to this menu here. Again, follow along, please. Delete any graphs you have here. And let's type in this second one. Negative. How do I type log base 2? Log x over log 2. That's a conversion factor. It's called the base change law, and it works. And then, now, in theory, what this should do is this should take a log and flip it the same way parabola. There. Now, Matt, that looks kind of like an exponential, but do you notice it goes through the x-axis? It's not asymptotic to the x-axis. That's how you know this is a log graph. What's the x-intercept? Find it. G-solve root. Also 1, 0, so I was right. Is this graph, Mackenzie, as it moves sideways, getting bigger or getting smaller? Look at the graph. As it's moving that way, are we getting bigger? Are we getting smaller? Smaller is decreasing. Further from 0, but more negative. What about this last one here? Again, let's go back to here. Delete this. And let's type in this equation, which is 2. How do I type log base 5? Log x over log 5. Draw. Increasing or decreasing? What's the x-intercept? Double check, is it? Yeah? And the reason I said double check is that number changed the y-intercept, but apparently it doesn't change the x-intercept. This one here, out of 9. Can you give yourself a score, please, on the top of this quiz out of 21? So Taylor, in the last lesson, listen close, here's what I said. I gave you the equation, and I said find a data point. Okay? Today, I'm going to give you a bunch of data points, and we're going to learn how to use technology to come up with the equation. But it has to be a bunch of data points that we're going to have to enter into our calculator, because our calculators are stupid. If I give it 2 points, even if they're from an exponential curve, you know what your calculator is going to assume is connecting them? Straight line. If I give it 3 points, it's probably going to assume it's a parabola. In fact, what we have to do, Brianna, in this method is we have to nudge our calculator into the right guess. We have to look at the data points, see what they look like when they're graphed, and say, I think that's this kind of a graph. Try that. So it's lots of graphing calculator. You have yours here too? Everyone's got theirs? If you'd be so kind as to turn to lesson 5, which is page 225. This one here. Okay. Basically, Ty, we're taking lesson 4 and reversing it. Instead of giving you the equation, find a point or two. Here I'm going to give you a bunch of points, find the equation. There's a fancy name for this. If you have data, if you do, and if any of you go into medical research or any kind of research, you'll find this very useful. If you have data and you want to try and figure out what equation or curve or line best fits the data, we call that regression. There's entire courses on nothing but statistical regression where you're trying to find the equation that best describes your data. We are going to, Matt, cook the data quite a bit so we get nice equations, but I'll try and talk to you about how you could tell in real life whether you had good data or bad data. So, here's the first one. It says this. Simone, a medical research scientist, is investigating a new bacteria culture, and it could help strengthen a person's immune system. She isolates 50 cells, and she records the growth in the number of cells over a period of 5 hours. See the table. After 5 hours, how many cells were there grand total? Read the chart. After 5 hours, how many cells were there? 380. Okay? Let's do a quick rough sketch. So after time 0, there was 50. Oh, no, sorry, we're going up by, if 2 squares is 100, I guess 50 must be right there. After 1 hour, how much was there? 75, which would be halfway between 100 and 50. I'm eyeballing it. This is a very rough sketch. After 2 hours, how much? So 2 hours, a little bit past the 100, kind of like that. Now, right now, if I connected these, Taylor, I might be tempted to say they're in a straight line because they kind of look it. Taylor, after 3 hours, how many were there? 169. Which is past 150. You know what? Probably halfway between 150 and 200. After 4 hours, how many were there? 4 hour, 253. This is starting to look, it still looks kind of like a line, but I'm getting the impression that it's getting steeper. What does every exponential graph look like, Matt? You know what? It's kind of maybe looking like that. After 5 hours, Matt, how many were there? What we want to do is come up with the best possible fitting equation for this data. Because once you have that, then you can use it to make predictions and analyze it properly. First of all, it says from the list below, select the best alternative for this. Linear would be that. Well, that's close, but you can see there's lots of points above and below. So I'm going to go no. Quadratic, this could be part of a parabola. It kinda looks like that. It kinda does. Exponential, it does look like maths as well. Logarithmic, those look like that. I no. So I'm going to cross that out. Now, I know that this is exponential growth because I know, for what it's worth, Hannah, that bacteria follow exponential growth patterns. So I'm going to say, we're going to circle this. How do you know, Mr. Dueck? Because that looks like it could be half a parabola. And I'm going to say, Laura, I just know. Also, we're in the exponents unit. How could we find the actual equation? We're going to get the actual equation from here? Yeah, we are. Get out your calculator. We're going to a whole new menu. Menu stat. Is that menu number 2 for you guys?
Yes.
Okay. Do you have data in there? Okay. So if you have data in there, look up, please. All of you that have data and all of you that don't, look up. I know, but I want them to look up anyway. Thank you. Look up. To delete an entire column, it's F6 arrow sideways, and then delete all, F4. So if you have stuff, clear it. And then hit F6 one more time to get back to this menu. Now, unfortunately, the workbook instructions are for the TI graphing calculators. They're similar, but different enough that we're just going to do this. Okay? Ready to go? Cleared it out? What we're going to do in list 1 is we're going to type the first column. 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. And then next to the 0, we're typing. I'm going to put the 50, the 75, 112, 169, 253, 380. By the way, when I was in high school, Taylor, we did this by hand, and this would have taken, for one question, about 20 minutes per question. So be grateful for the technology. I remember doing regression. Ugh. Talk about regressing. I felt some aggression towards my regression. Make sure that you have 6 and 6. Make sure you didn't miss one. Make sure your columns are balanced. And when you're done entering the data, look up just so I can see that you're finished. Kyle, you done or still typing? Okay. So then look up there. What we want to do, ready? We want to do some calculations. Help me out. What am I going to hit if I want to do some calculations?
No.
F2. How many columns do we have? We want to do some 2 variable oh, hang on.
I don't have that long part.
Got to get back to the original menu by hitting F6. Okay, hang on. Carson, actually, good point. All of you hit exit, back up one menu. What if I gave you the data and you hadn't graphed it and you just wanted to see what it looked like? Okay, what's that do? Let's go graph 1. It does a little scatter plot for you. There's no numbers, but you can at least see the shape, and you can say to yourself, maybe that's an exponential, or maybe that's a logarithmic, or maybe that's a sinusoidal, or maybe that's a parabolic, or maybe there's all these different types of curves out there. We are going to, over the next while, be doing a fair bit of regression of other curves as well. Oh, and is calc in here too? You know what? I was going to exit, but I see calc right there. 2 variable. Oh, hang on, I got to back up. Hit exit. Let's go back to this one here. Calc. And I made a mistake. We don't want 2 variable. We want to do regression. Regression. REG, F3. Now, what you should do is double check to make sure someone has been mucking around with your calculator. So can you exit your way back to this menu here? You may end up all the way here and then hit calc again. You should get in the habit of setting things up properly. How would I set things up properly? Okay, F5. And what you want to double check is it's saying, look, do you want your X list to be list 1 and your Y list to be list 2? Yeah. But by the way, if you wanted to, Mackenzie, maybe you wanted to keep this data, but you have more data, you could type a new list into list 3, your X values, another list into list 4, and you could change it here saying, yeah, I want you to look at list 3 and 4 from X's and Y's. So there's lots of customization. Yeah?
Should mine look like that?
It should say X list, list 1. Y list, list 2. Does it say that?
It says list 1, list 2, list 1, list 2.
Does yours say different from mine?
I have list 1, 1, list 2, 1, list 2, 1, list 1.
Does, sorry, Darian?
Yeah.
Does it have the same headings here on the left?
Yes.
Okay, so navigate with your arrow key until you're on the one that's different,
Yeah.
and press the list button.
Okay. And then put 1.
Yeah. Okay. Are we there? Are we there?
Yeah.
Yeah? Okay. So I'm going to back out of here, but you should get in the habit of check. Now, since this is yours now, my only worry was someone from last year might have done something wonky, but now that it's yours, Darian, unless you muck around with it now, it'll assume list 1 is your X values, and list 2 is your Y values, so stick with that habit. Exit. Regression. Here's what it's saying. It's saying you need to tell me what you think this is. Do you think it's a line, an X equation? I'll try and see if I can get the best equation for that. Skip the median. Do you think it's a parabola? Do you think an X cubed? Do you think it's an X fourth? Actually, we want to go arrow sideways. F6. Matt, what kind of an equation do we think this is? So, now here is where my calculator is different from your calculator. So hit F2, and I think you guys have a different screen than me.
Yes.
So I'm going to pause for a second. For you folks, your next step is to either go with a generic base or base E. Just so all of our answers look the same, choose the option that has a little base E in it. Is that F1 or F2? Look at it's giving you a template of the equation. It's saying, I'll find A for you, I'll find B for you, so hit that. So that you should have an equation. I think now your screen looks like mine?
Uh-huh.
Yeah.
Okay. Yeah? Sorry? Oh, yours goes straight to base E, so it's the newer models. All right. And this is the way all of ours look the same. Here's what it's saying. Yep. You got an error? Okay, hang on. Okay. At the bottom, for any regression menu, Brianna, they're going to show you the equation template. So it's saying, look, your equation looks like this. Y equals A times base E, that weird funky number that we talked about, to the power of B times X. In fact, right here, we can write, we got room right here, Y equals. So this is the template, except what's A? It calculated what A has to be for me. See it? Now, 49.9473899. If I was guessing, I bet you it might be 50, but I'm going to go 49.95. Times E, and then to the power of BX. What's B? 0.40571. I'll carry a few extra digits. 0.4, what was it? 0.40571x. This is the equation that best describes those 6 points that we typed in. And I can even tell you how good it is. They've done that as well. This number here, R, is called the correlation coefficient. The closer R is to 1, the better your data. What's our R value? 0.9999964. Matt, what that tells us is our guess that this is an exponential function was probably good. If you were doing research, what that would actually tell you is these people here are going to make billions. They have found something that strengthens immune systems in a one-to-one correlation. That never happens in medicine. In medicine, by the way, most of the drugs that you take, most of the things that you take, have an R value, a coefficient value of about 0.2. or 0.3. And that's an improvement. It's better than 0. If you ever did get an R value in medicine of 1, sell the farm, invest in your company, you're going to be rich. Okay? Only, look up. What's Y really talking about? More specific. You know what? I would actually write it this way. N equals what do you think that 49.95 is that's really close to 50? Where did a 50 appear in our original equation? That's usually going to be your original amount. It should be a 50. I'm going to write 49. I'm going to commit to the equation, but I know that because there's probably some noise in my data, but 49.95 e to the 0.40571 t for time hours. That's probably how you would publish the equation, Mackenzie. I mean, you'd type it in like that, but you'd publish it with proper variables. Is that okay? So now we're going to read. It says this statistical process that we call regression, it's the mathematical way to get the best function, whether it's exponential or linear. And by the way, your calculators did some heavy number crunching. What it's really doing is trying a bunch of different curves, finding how far above and how far below the points are, taking an average and using that to get a better approach. It's doing a lot of heavy math. So the graphing calculator can be used to determine the best possible linear or quadratic or exponential or trig, depending on the pattern that you get from your data points. Here is for a TI-83 or a TI-84. I do have notes for the Casio, but I don't have them right now. They haven't installed themselves on my laptop. Hopefully by Monday I'll have them. Let's actually try a question. Oh, part 4, graphing the curve. Go back to your graphing calculator. You're still on this screen? What's it say in the bottom right? Copy it. And it automatically is going to, if I hit enter, it just pasted it into my y equals graph menu. So if you hit copy, which is F6, enter, try that. And I think now if you go menu, graph, there it is. That's handy. You don't have to rewrite it. Yeah. Okay, hang on. We're going to come look. You didn't want to put a marker there. So we're back to here. We've either copied it. Oh, too far, Mr. Dueck. Graphing the curve. So I can now graph this curve. I got one problem, though. Nope, I got 2 problems, though. Okay? Look up. Guys? Guys, look up. Candy, if anybody can see the first problem. View windows, the second one. Right now, nothing will graph. How come? No. No. So, use your arrow keys to go on this equation. It's not selected, it's been turned off. So if you hit select F1, suddenly you'll see that the equal sign is now highlighted. You guys that typed in by hand will automatically have yours selected, but for those of us that do the copy thing, for some reason it doesn't select the equation by default. Okay? It picks a good view window actually automatically. Maybe not the best one, but a good start. There's our graph. Now, I could also say things like, okay, after 4.5 hours, how many bacteria will there be? Or how long until there's 300 bacteria? Or now that I have an equation, I can find the data points like we did last day. Try one more. Ready? Example 1. I'll walk you through it all. You don't need to. Okay? So, here is some carbon dating. It says the table below shows data for 5 recently discovered functions, and it is telling us that this is going to be a logarithmic function. Okay. Go to your stats menu, please. Menu, stat. Go to your stat menu, please. Delete your data. For me, it's F6, delete all, arrow, F6, delete all. Then, let's enter the data that this question gave me. So it looks like in the x-axis, I have 95, 79, 68, 38, and 27. And on the y-axis, I have 425, 1950, 3191, 8,000, 80,000, 8,000, and 10,824. I want to calculate. Oh, I don't see calculate right now. Oh, arrow sideways. It's on the other menu. There it is. Calculate. I want some aggression. What? Oh, by the way, just to show you, I didn't bother, but graph. That looks maybe like a decay graph, but they've told us this is a logarithmic one. So I'm going to use a logarithmic. So calculate, regression. I don't want these ones. I want to do a log graph. Again, on the newer calculators, our menus are going to look a bit different. On mine, I go straight to the answer. On the newer ones, when you pick log, then pick the option for ln, for natural log, which I hope is F1? No? Yes?
I just clicked log and immediately brought me to that screen.
Oh, yours only gives you an ln base for that? Okay.
Yeah.
Here's what it's saying. First of all, Mackenzie, holy smokes, good data. My R value is 0.99999. Again, if you were doing research, you would dream of getting data that good. The correlation coefficient, it's saying whatever you're testing definitely has an effect. Here's my template. It's saying your equation looks like y equals a plus b ln x. What's a in this question? 38,067. What's b in this question? Negative 8. So, ready? As an equation, what's a? 38,067. Plus, what's b?
Negative 8,200.
Negative 826, I think 6 if I round off.
Okay.
ln of x. By the way, if you look up for a second, I'll never write ln like that because my l's look like 1s. So whenever I'm wanting to do the ln button, I'll do a handwritten ln like that. It'll almost look like a lowercase h, but not quite. Okay? Okay. Yep. It's over there. Only, look at the X value in my chart. What's X measuring? You know what? You could put a P there for percent. I'll leave an X there. And what's Y measuring? Age. You could put a capital A. I'll put a Y there. Then part C says, on a graphing calculator, display the graph. So for us newer ones, we can go copy and hit execute to store it. And so, Darian, when you were saying, or someone was asking, do we need to delete the equation? It just deleted the original that was there and put the other one on top of it. So I said, I don't need to, that's a waste of my time. Older calculators, you have to type this by hand, sorry. Menu, graph, draw. Condition error. Oh, I forgot to select an equation. You don't need to change the view. Oh, sorry, I don't want to delete it. You don't need to change the view. It'll come up with a good one automatically. Did you hit copy, execute? Does yours actually have the equation sitting right here? Then you didn't hit copy, execute.
No, but it's on the graph, but the equation isn't showing.
So for those of you who did not get a graph, so you have something that looks kind of like this but no curve, hit the zoom button. F2. Auto, which I think is F what?
Oh, there we go.
Okay?
There she is. Okay. Oh.
Not quite the same as mine, but close. Yes?
Yeah.
Okay. Folks, I want to finish this question just so that we don't have to re-enter all our data. So, you ready? Mackenzie, were you able to get it to appear or no? Okay, I'll come back to you. Now that we have our graph, guys, now that we have our graph, we can answer questions in part D. So in part D, what do they want me to find? An X value or a Y value? A Y value. That must mean they gave us what? What X value did they give us? 20.3. So let's go G solve. Y calculation, 20.3. And let's hope that actually fits and appears. Does it? You guys got an error. What kind of an error? Okay, look at your graph. Does an X value of 20.3 appear? Can you see the X-axis? Okay, so you guys, G-solve, view window. See what your X-min is. Does your X-min go as low as an X value of 20.3? What's your X-min? Your X-min is negative? Should be fine. What's your X max? What's your Y min?
23,489.
Your Y min is 23,000?
Yeah.
Not your Y max, your Y min?
Yeah.
Negative or positive?
Positive.
Okay, I got an issue here. Hang on.